going on Friday. In fact, Friday and Saturday. I don't have anything tomorrow, but I've got three scheduled today, oddly enough. So what are you working on, Simon, in class? What kind of math?
Right now in class, we're kind of doing like exponent stuff with like fraction exponents, kind of like adding exponents, subtracting exponents,
Okay.
multiplying exponents, stuff like that.
That equal to?
Oh, that's equal to 3 or cube root of 8 squared.
Which is 4.
Yeah, which is, yeah.
Okay. What's this equal to?
That's 8. Oh, wait, no. Sorry. That's, isn't that just 2?
2 to the what?
Is that subtracting? Because
No,
the way...
multiplication. And
yeah.
the way to remember
that's multiplication. Okay.
is, so you're going to add the exponents.
Yeah, I thought that, sorry, at first that looked like a subtraction sign, so I got confused.
Yeah, I apologize. That was my writing. Okay, tell me what this is.
That's just 2. 2 to the first.
Okay. And finally, tell me what this is.
2 to the 12th.
Okay. Those are the 3 rules of exponents.
Yeah.
That's pretty much all you need to know. Might be one other. What's that equal to?
0 to the 0. Is that 1?
Huh?
Is anything to the 0 is 1, right? Yeah.
X, yes, it is. X to the 0 power is 1, no matter what X is.
Yeah. And we're going over negative exponents, too.
Okay, let's talk about that. What's the way to represent that?
The way to represent that is 2 to the 1 over 3, right?
No, it's just the reciprocal. It's 1 over 2 to the positive 3.
Oh, okay.
Always. No matter what it is. Now, there's a couple of tricks with negative exponents. This is always true. In other words, first of all, notice that a negative exponent has nothing to do with negative numbers. That's a positive number. It's 1/8.
Yeah.
In fact, it would be almost impossible to take 2 to any power and get a negative number. In fact, not almost impossible, impossible. Now, the other thing about negative exponents is if you have something like that, the rule is you can always just move it to the other side of the fraction line.
Yeah, with 2 over 3.
No matter which side it started on. In other words, it doesn't just apply to numerators with negative exponents. It applies also to denominators. So if you have a negative exponent and you want to turn it positive, just put it on the other side of the fraction bar. Now, in a case like this, you say, well, there's no fraction bar. There really is. There's one right there. So if I'm putting that on the other side of the fraction bar, I'm doing that. And, of course, we need something in the numerator, which would be 1.
Yeah. And that would be 1/16, right?
Uh-huh. Do you have any specific problems you want to work on? That's the best way to learn this stuff, is specific problems.
Yeah, let me get out of the worksheet really quickly.
Okay. If you can verbalize them, fine. If you want to take a picture of that and send it to my email, that might be better. Depends.
Yeah, I think I'll try and verbalize them, but I don't know, because a lot of the stuff we're doing right now is actually with fraction exponents.
That's no problem to verbalize.
Yeah, okay.
The stuff that's tough to verbalize is graphs. In other words, if they do a graph and they say, what is this, what's the function, then that's going to be hard to verbalize. But and you'd want to send a picture. But if it's just fractional exponents, you can just give me what it is and we'll work on it.
Okay. Well, okay, we can go over a few of these. let's see. Can we, okay, so this one, number 5, it's 8 parentheses x plus 1 and parentheses to the 2/3 power equals 512.
Okay. First of all, let me give you a different problem. X to the 2/3 equals 10. How do I solve that?
What you would do is you would multiply x to the 3/2. You would do the inverse of 2/3, and then you...
Okay, you got the right idea. Your terminology is a little bit off. First of all, you're not multiplying. You're exponentiating.
Oh, yeah.
And you're exponentiating to the reciprocal, not the inverse.
Reciprocal. Yeah, that's the word that I couldn't figure out.
So
reciprocal.
I knew this is what you meant.
Yeah.
And if I'm going to do that to the left side, then I'm going to do it to the right side.
Yeah, exactly. And then
multiplying exponents gives you a 1 for an exponent, and whatever this number is, you can get a calculator.
Yeah.
Okay, so now if we go back and look at your problem, notice that one thing you have to do before you can take it exponentiate to a power is get it isolated. In other words, before we can do anything, we've got to isolate that right there.
Yeah.
Because that 8 is not being taken to that 2/3 power.
Yeah, you can divide the 8 from both sides.
Gotta get rid of it, yeah. So if we divide both sides by 8, we're left with this on the left. And what is that, 64?
Yeah.
Okay, now we've got that thing isolated, and we can exponentiate it to the 3/2. So we're going to take 64 to the 3/2. That's going to give us x plus 1 on the left. What's 64 to the 3/2?
So that's 4 times, so it's 16.
It's the square root of 64. Always do the root first.
Oh, shoot, yeah, sorry, I forgot to, okay. Yeah, no, square root of 64, what is that, 16?
8.
8. Oh, screw, yeah, sorry.
And
8, and then you cube that.
Cubed is 512, believe it or not. In other words, 8 times 8 is 64, times another 8 is 512.
Yeah.
So, x is equal to 511.
Okay.
Okay? So the secret on all of these problems is to isolate the exponential part.
Wait, and I don't know, but I think, but my teacher said that if the exponent is a fraction and it's low, if the denominator is even, then there's 2 answers, is plus and minus.
Yes. Whenever you take the square root, it's like saying 4 to the 1/2 power is actually plus or minus 2.
Mm-hmm. But the only difference with this one is the answer would be...
Well, we have an odd. No, we had an even. Ah,
yeah, it was 3/2.
Ah, okay. Excuse me. Hold on. Let's take a look at that again. I left out the plus or minus, didn't I?
Yep. So that's the only reason why I was bringing it up.
And the minus 8 cubed would be minus 512. So that would be plus or minus, which means x is equal to either 511 or minus
negative 513.
513. Now, you bring up a really interesting question in math. That if I take this number, a negative number, and take it to the 2/3 power, what do you think that is?
Well, that would be That would be -2. That would be 4.
One would think that's what that would be.
Really?
But
Is it?
well, it's a very interesting question. I spent a half a day researching this problem.
Huh.
If I do it on, are you familiar with Wolfram Alpha?
No, I have no idea what that is. Never heard of it.
It's a knowledge database, and it's probably the premier math database.
No, okay.
It'll do pretty much whatever your calculator will do, only easier. And it'll also answer questions like, what's the population of Russia? So,
Really?
yeah,
Okay.
it's a computational knowledge engine. It's pretty cool if you've never used it. But
And it looks like it has like a lot of. It's just not just mathematics. It's
yeah,
like it's kind of like it's almost like Khan Academy kind of.
yeah, well, it'll answer any function. It'll graph any function. It'll give you the zeros automatically. Watch what it gives you for this answer. Notice,
4 to the negative. Huh.
now look at the decimal approximation it gives you. -2 plus 3.4i.
Why is it like that?
Nowhere does it give you an answer of 4.
Huh.
And it's like that. It's not accidental. It's correct.
So you were researching about it, right? Like, do you know why it's
I
like that?
did a lot of research about what happens when you take a negative number, like -8 here, and take it to a fractional exponent where the numerator is even. In other words, if I have -8 to the 1/3 power, that's -2. Let's see if Wolfram Alpha gives us that. I'm a little curious now.
Yeah, because I saw a lot of those 1/3 too.
So there's to the 1/3. That should be a clear-cut -2. If it isn't, then my theory is off on this. No, okay, I must be wrong. In other words, it doesn't really give you a clear-cut -2. It does. In other words, this result, the cube root of -1 is -1. -1 times 2 is -2. So it does kind of give you that. But then it also gives you the imaginary results. And the imaginary results are actually true. The question is, how come it doesn't give you -2 as a result? And if I replace that 1 with a 2, it doesn't, yeah, I guess it does give you the -4 result, because that would be that would be +1 times 4 would be 4. So I'm not totally sure what's going on. I did research it once, and it turns out to be quite a bit in the realm of higher mathematics, where I don't know if you've ever studied de Moivre's theorem. You won't get that probably till pre-calc. And
Yeah, I have no idea what that
then, but when you start looking at the nth roots of numbers, including complex answers, then you encounter strange things like this, like negative numbers to fractional exponents. So anyway, that's why I didn't think of that answer, was that I didn't like the idea of x plus 1 being negative. And if we use the answer -513 for x, then we're going to have a negative number to that fractional exponent.
Yeah.
Now, I guess I'm going to have to do some more research on this. I had kind of come to the belief that there were certain negative numbers you just could not take to fractional exponents.
But I guess that's
fractional exponents, and I'm no longer sure that that's true. Because it should have told us -2 for the cube root of -8. I mean, everybody admits that that's -2. All right, so this is fine. I'll go with both of those answers, 511 and -513. What else you got?
So I was, well, actually, no, never mind. I think 3, this is the square root of x plus 19. And then outside of the exponent, it's minus 5 equals -1.
Again, whenever you have a radical in an equation, you want to get it isolated with the intention that once we get it isolated, we're going to square both sides.
Mm-hmm.
Okay, well, to get it isolated, we got to get rid of this minus 5. So we get this.
X plus 19 equals -4. Oh, yeah. Wait. Yep. Yeah, you're right.
Okay, and now we square both sides, or do that.
So that's 16. So x plus 19
Becomes
equals...
x plus 19 equals 16, x equals minus 3. And now let's check that solution. If we substitute minus 3, then we get the square root of 16, which is 4 minus 5 equals minus 1. So that's what we got, and that works. Now, whenever you're dealing with certain kinds of functions, you got to always check for extraneous solutions. And here's what gives extraneous solutions: radical signs, absolute value signs, or logs. If you have equations that have any of these, then be very careful to look for extraneous solutions. Now, I saw this problem the other day on an ad that said, "So you think you're a genius? Solve this."
So you would, would you cube the 3?
No. What we have to do is work with one square root at a time. So the first thing I'm going to do is move that to the other side in order to isolate the one on the left.
Oh, okay. So you just bring it over, you wouldn't square it?
Not yet.
Okay.
We're only going to be able to lose one of these radicals at a time. Once we get it down to one radical only, then we'll isolate it and square everything on the other side. So I've got this, so I'm going to square the left, giving me that. And when I square the right, I get 9 minus 6 root x plus x. Now notice that I've got an equation that only has one radical sign in it. That's that one right there. So I'm going to isolate it and move everything else to the other side. Well, first of all, I can cancel out those x's. That was kind of accidental. I didn't intend that. So I'm going to end up with a positive 6 root x equals 1.
Yep.
So root x equals 1/6. Now I square both sides again, and I get x equals 1 over 36. And that's the answer. But that's how you handle when you have multiple radical signs in one equation, is that you cannot get rid of both radicals in one step. You have to get rid of one radical, which is still going to leave one radical, and then isolate the last radical, square both sides again. That'll get rid of that radical. These are a level of difficulty you may not get.
Yeah, probably not in our thing. Like,
you'd certainly get this in an Algebra 2 honors, I would think.
Well, we would maybe get something like that. I'm an Algebra 2 honors.
Right, that's why I covered it, is I wanted to make sure you knew how to handle it.
This is like considered kind of like harder, like under the harder problems on this worksheet, but it's
Okay.
x, or if you want to, yeah, okay. It's x over the cube root of x squared, like parentheses squared.
Around all of it?
No, just the bottom one.
Okay.
That's considered kind of hard in my class.
Okay. Let's simplify the denominator. In other words, the reason I know I want to do that is because I got x in the numerator and I'm going to have x as the base in the denominator. So if I can figure out what exponent goes in the denominator, then I can apply the rules of exponents and just subtract the exponents. That'll be my answer. So what's another way of writing that?
X is 2 over 3, x to the
X
2 over 3
to
power.
the 2 over 3, exactly. Now we got same base, different exponents. Subtract the exponents, what do you get?
You get 1/3, x to 1/3.
And if they like you to put it back in radical format, in other words, sometimes if they give it to you with a radical sign, they want you to give them the answer back with a radical sign. If I had my way, I would never use a radical sign. I would always use the fractional exponent.
Yeah.
Just because when you get to calculus, everything's based on the exponent. So whenever you have radical signs, you get rid of them instantly and change them to fractional exponents and go from there. But that's how you do this one also.
Yeah.
Yeah, kind of one way to look at this, if there's any confusion here, is let's take this cube root of x and immediately make that like that. Then we'll put parentheses around it and square it.
And then it's made kind of easy.
Well, yeah, then you're just going to multiply the exponents to get this 2/3 here. It's only confusing when you have kind of a combination of radical sign and exponents. Then it's a little confusing. So the best way to handle that is just convert everything to fractional exponents instantly.
Yeah. But after you get, is that the answer though? Like 3 to the x?
No, that's not 3 to the x. That's x the cube.
Or x cubed.
That's x to the 1/3 or cube root of x.
But that's the answer, cube root x?
Yeah, because what I had was x to the 1 divided by x to the 2/3. Well, I'm going to subtract the exponents. That gives me that.
Okay.
It really wasn't hard. It was hard only because they mixed up radicals and exponents in the same expression. Had they not done that, had they given you the problem like that, you wouldn't have had any problem with it at all.
Yeah. But here's another one.
Okay.
I think I did this one wrong, but it's cube root.
When you say cube root, they're always giving you the radical sign?
Yeah.
Okay.
X squared equals 16.
Again, let's change this whole thing to a fractional exponent. Then we can solve for x. So what's that equal to?
That's 4. X equals 4.
No,
right?
Well, it's not even, you're way ahead of me.
Yeah, okay.
It's not x equal 4. What's the fractional exponent of the thing on the left?
It's x to the 2/3 power.
Now we're in business. Now what's the next step?
What's the next step? The next step is to root that number by 3 over 2 and also, or not root it, but square it.
Exponentiate it is what you're looking for. What you're doing is, that's called exponentiation.
Okay.
Okay, so I'm going to exponentiate it to the 3 halves or the reciprocal of that number. That will leave x all alone there. And what's this equal to?
That is equal to, wait, hold on, let me think. Is that, oh shoot, no, I'm thinking about it all wrong. That's 64, right?
It is, although from what you said before, your teacher's going to say that's plus or minus 64.
Yep.
Because when I take the square root of 16, I get plus or minus 4. When I cube plus 4, I get 64. When I cube minus 4, I get minus 64. So I'm guessing that is the right answer. You know what? Hold on a second. I'm a little confused here. I'm going to check this in Wolfram Alpha. Let's make sure that it gives you the same answer. Just a second. What I want is x to the 2/3 equals 16. That's what I want to put in. X to the 2/3 equals 16. What the heck happened to my Wolfram Alpha? Okay, here it is. So x raised to the 2/3 power equals 16. The beauty of Wolfram Alpha is it gives you feedback as to what you put in. You know, sometimes it can be hard to put these expressions into calculators with all the parentheses and everything.
Yeah, for sure.
It's nice to see your input.
Oh, and the solution is 64.
It is 64. It's not plus or minus. Oops. Yeah, it's not plus or minus. Even though we have to take both sides to the 3/2 power, 16 to the 3/2 power, they're saying, is 64.
Yeah. So it's, that's weird.
It is a little weird. I'm not quite sure I understand what's going on. Which means that if I say x to the 0.5 power, it's not going to give me, I didn't mean x, I meant 4. 4 raised to the 1/2, which is the square root of 4. You would think it would give you plus or minus 2, but it's not going to. It's going to give you plus 2 only.
Yeah.
Yeah, which means when you go to a fractional exponent, it really means the same thing as a radical sign, as opposed to the following. If I'm ever solving an equation by taking the square root of both sides, in other words, if I have an equation like that.
Yeah. Well, wait, wait, can you go back to the Wolfram thing?
Just one moment. That's always plus or minus 2. In other words, if you are solving an equation by taking the square root of both sides, always begin your answer with the words plus or minus. Now, that's a little different than taking something to the 1/2 power.
Yeah, can you do like the opposite of that? If it's supposed to be plus or minus.
Well, actually, no, I don't know. Do the opposite. The only way I could do the opposite would be x squared equals 4. Then it will definitely give me plus or minus 2. If I put in the equation x squared equals 4, well, now minus 2 is as valid of a solution as plus 2. And gives you both solutions, plus or minus 2. But oddly enough, if I put in 4 to the 1/2, it only gives me the plus solution. And the only thing I can assume from that is that when you use a fractional exponent like 1/2, it's identical to using a radical sign.
Yeah.
And there's a reason the radical sign, in other words, there's a reason the square root of 4 is equal to just 2. Because if I want negative 2, I can write it like this. In other words, that's negative 2. In other words, there's a presumed coefficient of a plus sign in front of that. When I write radical 4, it's presumed I'm talking about the plus solution only. If I want the negative solution, then I can write it like this. And that gives you the negative solution. But what I wasn't aware of until today is that 4 to the 1/2 is also only equal to 2, not plus or minus 2.
Huh.
And that changes our other solution. When we got 511 and minus 513,
Yeah.
that would change to 5.
Just 511. Or 5.
511.
Oh yeah, 511.
I think it was 511. Yeah.
Yeah, it was definitely 511.
512 minus 1, or
Yeah.
512 minus 1. Yeah, so it was 511 and not minus 513. And that kind of takes me back to this issue of taking negative numbers to fractional exponents like that. There's something fundamentally funky about that. I can't explain totally what it is, but it's not quite as simple as it would appear.
But with that, is that website also like, would it normally give a plus or minus if it?
Yeah, it just did. When I solved the equation, x squared equal to 4, that gives you plus or minus 2. Right there, the solution's plus or minus 2.
Oh, yeah, okay. Huh. I'll need to ask my, I'll need to tell my teacher.
Whenever you solve an equation by taking the square root, your answer is always plus or minus. But on the other hand, when you take a number to a fractional exponent,
it's always plus.
It appears to be. Although, since I've ever taken math, everybody says that minus 8, the cube root of minus 8 is minus 2, without questions. The problem is that the cube root of minus 8, there's 3 solutions there. That's a cubic. And a cubic has 3 solutions, so it's not just minus 2, it's minus 2 plus a couple of complex solutions. And that's the higher math part.
So we'll learn that in like calculus or
well, there's find the 8 roots of 1. Believe it or not, that's a legitimate question. Find the 8 roots of 1. Well, clearly one of them is 1, and what else? Minus 1 times minus 1 is also 1.
Yeah.
There are 8 if you count complex numbers. And complex numbers open up all of these other solutions to these obvious math problems. And you actually solve for all 8 of them using de Moivre's theorem, where you convert it to polar trig coordinates, which are complex in nature, and you can solve for the 8 roots of 1. And like one of them is 1 minus I, one of them is 1 plus I. Those are roots, I think, if I remember right. But it's far more complicated than one might imagine.
Yeah, it sounds like it.
Yeah, I didn't know though that when you took something to the 1/2 power, that was the same as using a positive radical sign, apparently, according to Wolfram alpha. And I would think that if anybody's going to be right, Wolfram alpha is right. I'm not questioning their expertise at all. Maybe I should, but I don't think so. They're the ones affiliated with Mathematica and Math World, and they're the cream of the crop. If you wanted to use one online calculator, this is the one I would recommend.
Yeah, now if I want to get, now I know that if I want to get done with my math homework a little bit faster.
Well, there are certain things that I can do a lot easier on Wolfram alpha than I can a calculator, just because of the input.
Yeah.
Sometimes, you know, what you're inputting's got 3 nested parentheses, and getting those right on a TI-84 is tough.
Yeah.
Not so tough on an Inspire. An Inspire has a different display system, so they display exponents as exponents instead of having to put everything in parentheses and raise to powers. But yeah, Wolfram Alpha will always tell you what you put in, and that's very useful sometimes. What else do you got?
Hold on.
Yeah, I'm going to be curious to see what your teacher says on that one problem that we came up with minus 513 or plus 511.
Yeah, because I don't know if, I guess it would be kind of, you would think that it would also have to be negative times negative, right? But
Well, not necessarily. The
I don't
whole
know.
question boils down to what is that? If that's plus or minus 2, or is that just 2? According to Wolfram Alpha, that's just 2.
Yeah.
It's not plus or minus. Even though minus 2 times minus 2 is 4, it's kind of the equivalent of saying that, and that is just 2. That's not plus or minus 2.
Yeah, you're right, I guess. But anyways.
So I'm assuming that a fractional exponent means exactly the same as that radical sign in terms of interpretation.
Yeah.
All right,
But
what else you got?
this one I think is kind of easier, but I guess we could do it. It's x to the 2 over 5 power equals 4.
Okay, what's the first step?
The first step is putting it to the 5 over, there, you do x to the 2 over fifths, and you put that to the 5 over 5 halves power.
Here's the way you verbalize that. I'm going to exponentiate each side to the 5 halves power.
Exponentiate, okay.
Each side. Because I can do anything I want to one side of an equation as long as I do it to the other. And I mean anything. Take the log, integrate, differentiate, all these things you don't even know what they are. You can do them.
Yeah.
So I can exponentiate each side to whatever power I want. Once I do the left, I get x. And when I do the right, what do you get? What's that equal to?
That's equal to, what is 2 to the 5th?
That is 32. And again, they keep giving us these problems over and over and over that all test us on this question, whether we're talking plus 32 or plus or minus 32. Because, again, one might say that the square root of 4 is plus or minus 2, and when I take that to the 5th power, I get either plus 32 or minus 32. But not according to Wolfram Alpha. That's the only answer according to Wolfram. If I'm wrong, please let me know in the future. I would like to know.
Yeah.
And we'll see what your teacher has to say on these.
Yeah, I'll be curious to hear his...
It'll be very interesting. And if he says plus or minus 32, well, show him Wolfram Alpha.
Exactly.
Just go in and do 4 to the 1/2 power, and it only gives you a plus 2.
And he's a big math guy, so I bet he's heard about Wolfram Alpha.
Yeah, it's like the most famous math site, I think.
Yeah.
Okay.
Here, let's go over this one. It is, I don't think we've done this one yet, but it is minus 4 cube root x minus 1. So minus 4 times, yeah, cube root x minus 1.
Yeah, that's the way you said it. It just took me a while to figure it out.
Yeah, sorry. And then it's negative 8, or equals negative 8.
Okay. First step going to be?
First step is going to be dividing the negative 4 from both sides.
Okay, so I'm going to write this like this. I'm going to make that 1/3. And I'm going to divide both sides by negative 4, giving me 2 there. With me?
Yep.
Okay, next step?
Yeah, and the next step is to exponentiate both sides by 3 over 1.
So that gives you x minus 1 equals 8, and x equals 9.
Yes.
Hold on a second. It's an odd answer.
Why?
Well, that means that minus 4 times the cube root of 8 equals minus 8. Oh, no, never mind. I don't know what I was thinking. That's 2. I thought that was an irrational number. Trying to figure out how you could have a number times an irrational number equals a number. No,
Yeah.
I wasn't thinking. I had a brain moment for a moment. The cube root of 8 is 2. Okay, good.
Yeah.
So we're fine. Okay. I got thinking all these odd things about these things.
Yeah, especially for this, there's a lot of things to like kind of keep track of. But here's also another one. That one was kind of easy. This is x plus 1 exponentiated to the 3 over 4 equals 27.
Okay, first step?
First step would be to exponentiate both sides to 4 over 3.
So that leaves x plus 1 on the left. What's 27 to the 4 over 3?
No, that is what is 3?
Cube root of 27 is 3, and 3 to the 4th, notice, is the same as 9 squared.
Oh, so 81. Yeah, you're right.
So x is equal to 80. And notice also that on this problem we don't have any question. The cube root of 27 is clearly 3. It's not ever negative 3.
Yeah.
So it's only when you have even denominators that there is a potential question as to how to deal with it.
Yeah, that's true. Because, yeah, okay, that makes sense.
Let me ask you this. Hold on. Now see, this could get funky if I were to put that over there like that. What would your first step normally be?
It would be to exponentiate both sides by 2 by squaring it. Yeah.
So now I get minus 4 equals x squared. Now, to take the square root of both sides,
What is this?
can't take the square root of a negative number. In other words, it was a trick question. Not without bringing in complex numbers. In other words, that in itself is outside the domain. You cannot take negative numbers to the square root of negative numbers. So that does not exist, basically.
Wait, let's
try a complex number, but it's important to understand that complex numbers truly are imaginary. They're not real. They're strictly a tool. In other words, they're an important tool for a lot of higher mathematics. Imaginary. Have you had imaginary numbers at all?
Well, we've had i's, but other than that, no.
Imaginary numbers. That's what I'm talking about.
Yeah, okay.
I is equal to the square root of minus 1. Okay. So, but that's not a real number. If I said, what's the domain of x, the answer is all positive numbers. X is greater than or equal to 0 only. I don't include negative numbers in that domain.
Yeah.
Without imaginary numbers, you cannot take the square root of negative numbers. You can employ imaginary numbers, but like I said, these are a tool for much higher mathematics that they're not an insignificant tool. I suppose you'd be a little bit like an imaginary friend. If you were alone on a desert island being raised by a pack of wolves, you might have an imaginary friend that would be a tool for your survival, a useful one. Nonetheless, they're still imaginary. They don't exist.
And This problem just caught my eye. I think we can maybe fit it in, but I don't know how hard it is. It kind of looks interesting, but it's a exponentiated by b over 4 equals 16.
That's it? There's a problem.
Yes.
Okay, notice what the problem is. We've got two variables and only one equation. You can never solve two variables with one equation. You need another equation. In other words, I can do what we're talking about doing to both sides, but I'm never going to solve for A and B. All I'm going to do is I'm going to get A by itself, and then you've got 16 to the 4 over B. So that's the best I can come up with in way of an answer. And that's always the case when you have two variables. If I say x plus y equals 10, there are literally an infinite number of answers.
That's true.
I can solve for x, but only as a function of y. I cannot solve for the number x.
I think...
Same with this
one. Hold on. I think it... Well, hold on, let me read it. It says if that number equals 16, for positive integers a and b, what is one possible value of b?
Oh, okay.
So you're just solving for b. Sorry, I should have read that better.
Value of b.
Yeah.
Well, if b were 16, I'd be taking the fourth root of 16, which is 2.
2, yeah.
So you give me a B and I can give you an A, but there's lots of different answers. If B were 1, then A is going to be 16 to the 4th power.
Wait, hold on.
But I don't believe there are any equations that have two variables that you can solve with a unique solution with one equation.
Yeah.
That's just a fact of math. You need as many equations as you have variables, and in fact they all have to be independent of one another. My problem where I said x plus y equals 10, well, that doesn't get any better if I add this as a second equation. That doesn't add any information. I still can't solve it. Even though I have two equations now and two unknowns, they're not different than one another. Equation number 2 is the same as equation number 1. So I still can't solve it. So not only do you need as many equations if you have variables, but they have to be independent from one another also.
Yeah, I just thought that that one was interesting because, like, I don't know.
Yeah, as long as they don't mind that answer where A is a function of B instead of, Yeah. Well, and they said give one possible answer for B. Well, there were literally an infinite number of answers for B. Literally.
Oh, yeah, exactly. But we have these SAT problems, or my teacher puts these SAT problems on the worksheet.
Okay.
And that was actually just one of the SAT questions that he put on there that we just did. And this is another one.
Okay.
And it's kind of like a multiple choice. So is it okay if I read the answers out too?
Yeah, part of SAT is multiple choice, but part is non-multiple choice also now.
Yeah, it's kind of weird too. It's like basically you have to.
The last one I'm guessing was probably a multiple choice one. And
no, the first one wasn't.
Huh.
The one with the A and the B.
Where they said give one possible answer for B?
Yeah.
Yeah, well, you could actually give any number you want. I could have given any B I wanted. Remember what the answer was? It was A equals 4, Or
over 16.
16 to the 4 over b.
Yeah.
I could give 0. No, I couldn't give 0. That's the only b I can't give as a possible answer. I could give 1, 2, 3, 4, 5, 6, or negative b's. I could give any number on the number line except 0.
Huh. Okay. So that's just like an easy one, but it's catching the people, I guess, that just forget how to do it.
I suppose. I'm not quite sure what they're trying to do there.
Yeah.
What's your other SAT one?
The other one is, which of the following is equivalent to 3 or to 9 exponentiated to the 3/4? And the answer choices are cube root 9, whatever 4 root 9 is. We got just square root of 3. And 3 times the square root of 3.
Well, clearly that can't be right.
Yeah.
Because that's 9 to the 1/4. Okay? And that's exactly what we're looking at, is we're looking at the 4th root of 9 cubed. In other words, that's another way of writing 9 to the 3/4.
Yeah.
Well, the 4th root of 9 cubed, that is the same as the 4th root of 3 squared cubed, which is 3 to the 6th.
Yeah.
And now we're going to be able to get to the solution, I think. Let's see. The 4th root of 3 cubed. Notice I can pull a 3 out of that. In other words, here's what that is. That is the 4th root of 3 times 3 times 3 times 3 times 3 times 3. Well, those 4 3's, the 4th root of that is 3.
Mm-hmm.
So I can pull a 3 outside, and what I'm left with is the 4th root of 3 squared, which is the same as the square root of 3. In other words, that is 3 to the 2/4 power, which is 3 to the 1/2 power. So our answer is 3 square root 3.
Huh. I'm going to need to practice that stuff. Hopefully we get some more of these problems.
That's a toughie. The way to really handle that is to express the 9 in terms of 3.
Yeah, for real.
Write 9 as 3 squared. And then once I write it as 3 squared, now I can apply the rules of exponents and write it as 3 to the 6th. And once you have more than 4 of them inside there, you can always pull one out. In other words, as long as this number is bigger than that number, you can pull a 3 out. If that was 3 to the 5th, I would pull 1 out and leave 1 behind. Since it's 3 to the 6th, I'm going to pull 4 of them out and leave 2 behind.
And then, yeah, okay, that makes sense. Anyways,
Simon, that looks like probably a good place to stop if you don't have any last questions.
Yeah.
Okay.
Well, thank you.
You're welcome. Good luck on your quiz.
Okay, see ya.
All right. Bye-bye.